Good morning, everyone. I'm Nawanith. I'm PhD student from the Laboratory of Aquatic Animal Health Management. Today, I would like to present some part of my thesis. The potential of good polysaccharide extract from green seaweed on anti-yellowhead virus activity in Pacific white chimps, Lithopenes venami. Firstly, I would like to introduce about Pacific white chimps. Pacific white chimp is one of the major commercial chimp species of the world. Since 2003, the Pacific white chimp production has become in Thailand from 22,000 farms in coastal area from southern and eastern. Because of the ability of this species to adapt to a wide range of salinity and temperatures and to crop the disease under high-intensity culture conditions. However, the chimp culture are often affected by the foreign pathogen, creating a serious economic problem for chimp farming in many parts of the world, such as yellowhead syndrome, white spot syndrome, Tora syndrome, white fecal syndrome, and vivosis. In 2013, the most serious decline of 50% of chimp production of Thailand was a result of early mortality syndrome or acute hepatopancreatic necrosis disease caused by Vibrio parahemolyticus AHPND strain. For control the disease outbreak, chimp farmers are using an antibiotic and synthetic drugs for aquaculture operation, but it has many side effects about residual effect, resistant strain development, and environmental hazard. For the good management, control chimp health and quality of chimp production by natural substance has been used as necessary strategy for chimp cultures. The alternative strategy for chimp disease, we use an immunostimulant. The immunostimulants are the actually additive that enhance the innate immunity or non-specific immune response and increase resistance to specific pathogens. Its 5 types of immunostimulants used in aquaculture, including biological substance, yeast derivatives, nutritional factors, animal extract, plant or seaweed extract. For Thai local seaweed, the seaweed may belong to one of several groups of multicellular algae. It has 4 divisions: Cyanochyota, Chlorophyta, Phaeophyta, and Rhodophyta. The seaweed farming was slowly growth in the east and the south of Thailand that can produce Cassilaria fisherii, Solilia robusta, Ulva rigida, Coroba lentidifera, and Ulva intestinalis. In the present, we use seaweed as a functional food. Seaweed are the most important source of non-animal derived sulfate polysaccharide. The sulfate polysaccharide present in extracellular component of marine seaweed. The sulfate polysaccharide are important bioactive compounds. It exhibits many beneficial biological functions and pharmaceutical activities, such as antioxidant, anti-cancer, anti-inflammatory, antiviral, and immunomodulatory properties. The major sulfate polysaccharide found in marine seaweed include carrageenan from red seaweed, fucoidan from brown seaweed, and ulvan isolate from green seaweed. However, the study of seaweed application in aquaculture was limited in the topic of wastewater treatment and water quality management on aquaculture. Therefore, marine polysaccharide for marine seaweed have a potential to be the new functional strategy in the pharmaceutical field for aquatic animals for increase the immunity and decrease the drug and chemical use in shrimp cultures. Based on previous information, this study aimed to analyze the chemical composition and structure of polysaccharide from Thai local seaweed extracts and to study the antiviral properties of polysaccharide from Thai local seaweed extracts. In methodologies, I separate my experiment to 4 steps. The first step, I correct the seaweed Unva intestinalis, Unva rigida, Colopa lentilifera from Peshbury Coastal Aquaculture Research and Development Center. Second step, the seaweed was extracted by hot water extractions. In the third step, the seaweed were analyzed, the chemical composition and structures. In the last step, efficiency test, and study about antiviral activity of hot water food extract with shrimp pathogen. In all these experiments, I used commercial purified UVAN from Unva americana as a controls. Result and discussion. The chemical analysis of hot water food extract from 3 Thai local green seaweed on the sulfate contents. The result revealed that hot water food extract of Unva rigida were significantly higher sulfate content than another species, a maximum of 13.4%, followed by Unva americana, Unva intestinalis, and Colopa lentilifera. However, the uronic acid and carbohydrate contents of Unva americana at 41.5% and 64% were significantly higher than Unva rigida, Unva intestinalis, and Colopa lentilifera respectively. The biochemical composition may mainly depend on the seaweed species, collection season, growing area, environmental factor, and extraction method. For the structure composition of hot water food extracts of 3 species of Thai local green seaweed were analyzed by Fourier transfer infraspectroscopy or FTIR. A typical infraspectrum of UVAN show the 2 carboxylate groups, 1 major band and 2 minor band of sulfate ester, and the signal between 1000 to 1200 per centimeter is dominated by sugar ring and glycosidic bond. And all UVAN spectra present a 1 strong band likely due to glycosidic bond from 2 main sugar, lactose, and gluconic acid. For the effect of hot water food extract on antiviral activity in Pacific white shrimp was also evaluated by injection of the shrimp with pre-incubate solution at 0, 1, 5, and 10 mg per milliliter of hot water food extract from 3 species of green seaweed and commercial UVAN from Unva americana. The results show that the concentration of Unva intestinalis hot water food extract significantly lower cumulative mortality than positive control along experimental period. These effect properties was clearly supported by viral load in gills and hepatopancreas of Unva intestinalis, significantly lower than the control groups, by quantitative real-time RT-PCR. Although the Unwa intestinalis hot water could extract yellowhead virus injected group show good survival rate, the viral load in both the gill and hepatopancreas of moribund chimps was not significantly different from surviving chimps. This result suggests that 1 to 10 mg per milliliter of Unwa intestinalis hot water food extract were not perfect in controlling yellowhead virus infection. The yellowhead virus particle may have been inhibited but can survive at high dose without mortality. For the histopathology analysis of the pre-incubated hot water food extract yellowhead virus injection group, the target organ, gill and hepatopancreas of the virus clearly inhibit pyknotic nuclei and cardiolysis in the moribund chimp from yellowhead virus injection groups similar to the positive control groups. In the conclusions, the present study demonstrates that hot water food extract is effective method for sulfate polysaccharide. The highest percent of sulfate content in hot water food extract from Unwa rigida and the hot water food extract of Unwa moricana has highest percent of uronic acid and carbohydrate contents. The structure of hot water food extract of 3 species of Chilococcus seaweed have a typical infraspectrum of event. The anti-yellowhead virus activity shows significantly lower cumulative mortality of pre-incubation hot water food extract yellowhead virus of Unwa intestinalis injected chimps, supported by significantly lower viral load in gill and hepatopancreas. The hot water food extract of Unwa intestinalis at 1 to 10 mg per milliliter were able to strongly inhibit yellowhead virus infection. Moreover, the effect of the hot water food extract from Unwa intestinalis as a feed additive on the immune response and disease resistance in Pacific white chimp should be developed to new practical methods for disease prevention in the chimp culture industry. And now, my manuscript has been published in Malinda as part of the special issue antimicrobial compound from marine source and is available to download. Finally, I would like to thank Agricultural Research Development Agency for financial support and Peshawari Coastal Aquaculture Research and Development Center, Department of Fisheries Thailand for seaweed and experimental chimps. Thank you for your kind attention.